CEO, co-founder, as the CEO, co-founder of Beyond Benign, and we had a great conversation just about and connected over some of the initiatives that are happening out there, and thought this would be a great webinar topic to not only just explore the kind of evolution of green chemistry, but then also really some opportunities potentially to get involved and how to apply it. So with that being said, Amy, thank you very much for joining us.
Yeah, absolutely. I'm going to share my screen. And I applaud you for, providing resources and getting folks together around these topics. So thank you so much. Let me get rid of my closed captioning there. Really happy to be here and chat with you all about green chemistry. And I'm going to talk a little bit about our work at Beyond Benign, but also hopefully also give you kind of a bigger picture too. And if you have questions along the way, I'm happy to help address them. And if I can't answer them, point you in the right direction. So that's my hope. So as a chemist, I'm going to start with sort of my understanding of what green chemistry is and share that with you here. So I'm going to start off with that. Basically, I was I did an industrial postdoc with Roman Haas Electronic Materials, which became Dow and is now DuPont. But the point is I was working on some really interesting waveguide materials that go on touchscreen computers and handheld, those like now ancient handheld PDA devices. And I was designing basically that top layer. It's called a waveguide material. And how these devices work is basically you have a grid of light that's on the surface, and where you touch your finger, it interrupts that grid and sends a signal. And so then, the computer responds and knows where you touch. So if you can imagine, in designing a material that can do that guides light and really keeps light on the surface. There's very specific design criteria that we were designing for in our research groups, and things like it had to have a certain solubility because we had to coat it onto a surface. It had to have a certain melting point and glass transition temperature, so thermal properties. Computers get hot, so it had to have pretty robust thermal properties. So as it heated up, they didn't get it didn't get warped and misshapen if it didn't have the right thermal properties. It had to have certain mechanical properties. This is a polymer type material that you're touching in and day out, and so it had to have strength to it, but yet some give. So these very particular mechanical properties. Refractive index, which is basically a fancy way of bending light, something that can guide light. Also surface tension. Okay, so you get the point. We had a bunch of criteria that we were designing for. And what didn't really come up, yes, I came out of a PhD program, and my PhD was in green chemistry. So I was, sort of probably young and naive coming into our research groups. And I noticed there were some things that are missing from our design criteria. What about something like toxicity and environmental impact? And just as the same way, like as chemists, we design in and we design out properties all the time, right? So just the same way as if I designed a crappy polymer, that's the technical term, that didn't have the right thermal properties, I would go back in and redesign it, and I would design out those properties. I would make a better polymer that had more robust, better thermal properties, right? So, again, we do this all the time, and this is something that is typically void from those research discussions and in those group meetings where we're designing new materials. And this was very particular to the electronics industry, but you can imagine the design criteria around ingredients that go into cosmetics and personal care, and what those might look like. Oftentimes, we're not thinking of toxicity and environmental impact. So there's the design criteria, how we're designing our product in that, and the endpoint and understanding its toxicity and environmental impact. But there's also, where do things come from? Like what raw materials are you sourcing from? What are you using to make it? How is it made? And then, of course, where does it go? And hopefully this is a little bit more circular than what I'm showing here. What happens after its use? What's the end of life look for? So things like raw materials, reagents, solvents, energy, all the processing that goes into creating our end product. And then when we're creating the product, are there co-generated products in that process? And then of course, the end of life, what happens after use, how much waste is created, how, what happens to it at its end of useful life. And of course, like from a chemistry perspective and green chemistry perspective, you can categorize these into 12 different principles, which are wonderfully articulated in the book Green Chemistry Theory and Practice, if you're familiar with it, by John Warner and Paul Anastas. We're coming up to about 25 years of these principles, which is very exciting. And they're guiding principles, again, that refer to the product, so end of life, the product, how we design safer chemicals, the process, so the raw materials, the solvents, the feedstocks, the process, how it's processed, how much energy is used, what types of materials we're using in the process, and safe processes as well, and then end of life. So they consider sort of along that whole, a holistic approach, I would say, of chemical design. So to think about this a little bit further, I'll give you an example, again, out of your industry sector, but I think it's an interesting way to think about design. One of the case studies we have here is designing an effective refrigerant. And you can think of like the first class of, and this speaks to sort of our evolution of knowledge as well throughout the years. Our first generation of refrigerants back in the early 1900s, we were excited to have refrigerants. So we were basically designing for whatever worked. And that was what we were looking for in our chemical design. That was the sort of design criteria, whatever worked. And what we found is that some of these things that we've got are either explosive, or hey, if there's a leak in your refrigeration unit, you result in either people getting very sick or dying because of the toxicity of some of these early refrigerants. So then we came up with a new set of criteria in our second generation refrigerants, and we were looking to solve those issues. We were looking to solve the safety, the toxicity, so that if something did leak overnight, the whole family didn't, wake up or not wake up, I'm sorry, in the morning. But they were also looking for things that were durable and, not going to explode and things like that, stable. And they sure did find stable, right? So we know the next generation of these refrigerants were highly stable and persistent, not only in what we learned in the 70s and early 80s, was that these things were depleting the ozone layer. And we were starting to understand that they also had global warming potential as well. So then we're evolving. Now we've got a different set of criteria that we're designing for the more and more we know, and we're starting to phase out some of these properties. So we're moving towards these HFCs that removed some of the ozone depleting potential, but not the global warming potential. Those are still quite high. So now we have what's really interesting, a new class of refrigerants that where we have our eye on those endpoints, and we're looking to design specifically so that we can remove not only and have all of the safety and what we want from those first generation, but also have the no or low ozone depleting and global warming potential product. And this is really an evolution. This is a chemistry solution. So this is a chemistry solution to a global challenge. Oh, there's my global warming potential. So we're basically taking the global warming potentials and dropping it to nearly zero over time. We're not done yet, because these refrigerants work in some application, and some others they're still working on it, but we're getting there. So there's tremendous power in the way that we approach molecular design for our ingredients, for our products, for our materials. Of course, I'm a chemist, I'm biased. I do think it's a quite powerful way to address global and local hazards and impacts. To think about the case of detergents. Again, as we learn more and more, early detergents had all this branching from a chemistry perspective. That's what ends up making it highly persistent, and they would build up in our waterways. And we actually, back in the 50s and 60s, you would, in some cases, see foam coming out of taps because of the buildup of our detergents in our waterways. So this was a fairly simple solution to change the structure, right? And to design out these endpoints of taking that branch structure and just making it linear. And it turns out that this can be broken down in our waters a lot easier and again, a chemistry solution. So it turns out there's a lot we can learn from our past mistakes, and there's a lot we can learn about toxicity and impacts and hazards. And there's these wonderful, this is a great, oh, I don't even have the reference up here, but it's a great review on, there's actually design rules for how to design out design in biodegradability into a structure. From a chemistry perspective. So there's things that we can learn, about branching, as in that example of the detergent. And there's countless other examples of highly persistent molecules where we now have sort of a structure activity relationship here for understanding how the structure of our chemistry impacts that activity that we're trying to design in or out. So there's some really great tools at our fingertips from a chemistry perspective, which is exciting. So where does green chemistry sort of apply across a manufacturing process or a whole supply chain or a whole life cycle? To think about this, we think about, we'll have a look at this life cycle assessment. And we know life cycle assessments are not perfect, and there's a lot of considerations. But if you look at this, if you look at something like a detergent, again, I'm going to stay on our detergent example, Tide more specifically, where would you assume the greatest impacts might be? It turns out, I'll just sort of jump to the end. In this LCA from Procter & Gamble, it turns out it's actually in that product use or consumption is in their LCA, I should say, that they have, where you have a good amount of emissions, solid waste, toxicity in the product use and consumption phase. So this was a LCA that was done, I want to say, I don't have the dates on here, but oh yes, I do, 2001. So this led them to a new development of a new product called Cold Water Tide to really address that product use and consumption phase of this life cycle of a product, right? So then, they had another look and they said, well, okay, that's all good and well, there's a ton of consumer education that they had to do, and they still are doing around the use of cold water versus hot water in our own, use of our laundry at home. And that's a whole nother issue of changing human behavior. But it turns out that the next biggest impacts were found in these two phases of the product life cycle, right? The manufacturing and then that sort of end of life, in the end of life of the product, which is really interesting. So then they again went back to the sort of design formulation table and said, what can we do with this? How can we redesign out and reformulate essentially our product to address these and bring our impacts down? And so you might be familiar with Pure Clean. I feel like I'm advertising, but this is just a publicly available LCA sort of study to look at this. So I know in no way endorse one product or another. So, but what's interesting is this Tide Pure Clean is they're saying they want to make an effective product. And I think that, something in particularly in your industry sector in cosmetics and personal care, like you want things that are going to work. Otherwise, people are not going to use them. That has to be part of the consideration. But understanding the life cycle impacts and where you can design in and out these properties is, I think, hugely powerful as well. So that's just one example. Sorry, yeah, and here we are addressing UN Sustainable Development Goals as well. So how does green chemistry relate to this life cycle sort of view? This is a great review that sort of goes over those 12 principles that I mentioned earlier. Really apply across the board. They really apply at every stage of the life cycle. And but yet it is, as a preventative approach and a proactive approach, it is most impactful at that manufacturing stage. And you can see most of the 12 principles really hit within this manufacturing and processing and creation of products in that stage. So if we can think about how to do that better, we're going to be in a lot better place further on down the road. So again, green chemistry has a strong focus in these early stages of that product life cycle. I would say it has an impact of the product use and consumption in that end product that we want it to be non-toxic and safe for consumers. And then also end of life considerations. And ideally that's, again, more circular in a sense. And actually many parts of these are more circular. So green chemistry really applies across the product life cycle. So there's tremendous power in smart molecular design. Hopefully understand that, or understand my view anyway. From the refrigerants example to numerous other endpoints that can help us address not only global challenges, but local challenges as well. And what's really powerful from my perspective is that from a chemistry perspective, this is a bit of an exaggeration, I would say. The traditional chemist, I would say a traditional chemist probably does not go and reach for hazardous solvents or reach for hazardous reagents and intentionally create products that have high toxicity. But it might not always be in their criteria, right? It might not be in how they have understood how to select reagents or how to choose, and understanding that that their actions at that level create significant impacts further on down the line. For example, metal catalysis. Catalysis is one of the 12 principles, and that's basically a way of more effectively creating a product. Generally will reduce less waste and things like that. But your choice of catalyst has a huge impact. So if you're using precious metals that are rare, that are not widely available on this earth, and there's a limited amount of them, there's that issue. But then also just of how they're extracted, how they're used. So you can see the choice of an iron-based versus a platinum catalyst can have a huge impact in terms of sustainability. In this instance, greenhouse gas emissions. And there's countless other examples. And again, this is mostly focused on global warming potential and greenhouse gas emissions on this one, but there's a good number of other studies that can show you other endpoints where your actions in the lab as a green chemist, you're making these better choices and better, more thoughtful, intentional approaches can have real world consequences. So green chemistry in industry is on the rise. We're seeing a huge uptick in career opportunities, job postings on LinkedIn. There's a wonderful LinkedIn report talking about the green sort of movement in industry sector widely, but mostly in STEM fields. And what they're also finding is that many times the demand for students with these skills can't often keep up with the supply often can't keep up with the demand for students with these skills. But the good news is, so companies like, I'm just showing you a couple open access tools. Sigma Aldrich, Millipore Sigma has a dozen 2.0 tool, which we've developed some educational materials around if you want to learn how to use it. But basically, it's an open access way of analyzing your chemistry according to the 12 principles. This is from a fragrance company, Main. I always get it wrong, so it's one of those. I apologize if there's anyone who gets offended by that, but they have a wonderful tool, open access tool called Green Motion, and this is coming from the fragrance industry, where they have they've created a tool, again according to the 12 principles, to help them analyze their fragrance ingredients and formulations for according to the 12 principles of green chemistry. So there's some really great tools, and there's others that are coming out, particularly that I've seen in the additional pharma sector, the pharmaceutical sector here from the ACS Green Chemistry Institute. Pharmaceutical Roundtable also has a good number of open access tools. And they have some really great tools for metrics, solvent selection guides, tools, reagent guides. And this is much of it, some of it is very focused on synthetic organic chemistry, but there's also some really great pieces like solvent selection guides if you are doing things like extractions and sometimes formulating that could be really helpful resources as well. So there's a growing number, I would say, and this is not exhaustive by any stretch. So these are just a couple examples of what is out there that that's coming in from industry. So I mentioned that, there's a growing demand for students with these skills. And what's exciting, from our perspective as an education organization focused on education, we're not going to get to a point in the future where we go, oh, geez, wasn't that silly? We went through a phase of wanting people to think of sustainability in the environment. No, like this is the direction that we have to go within the field of chemistry and also just broadly within science, engineering, technology, in order to support a sustainable planet. So if this is where we want to go, we want sustainable, greener chemicals, benign materials, processes, and products. And we want these in support of a sustainable, healthy human and environmental, sustainable human environmental health, basically a healthy planet. This is our vision. This is what at our organization, I'm going to shift a little bit and talk a little bit about our work. So we envision a world where basically anything you pick up off the shelf, anything you use, you touch, we know we're a long way off of this, but we envision this world where anything that you pick up is safe and healthy for humans and the environment. And that's where we want to go. And I think that's where we hopefully all collectively agree that we want to be. And maybe we could debate a little bit about healthy and safe and those definitions too. But where does it start? We think it has to start in how we get there. At the core really is education. And that includes K through 12 and university and college level. And this is basically our mission. So our mission is to that human resource, that pipeline that feeds and supports the design and the development of more benign materials. We want to empower educators primarily because educators are catalysts and really help, to support and sustain the change. So this is our mission: empowering educators to transform chemistry, not a small feat here for a sustainable future. There's many steps in between, and if you're in your industry, you probably understand that there's some innovation that needs to occur too, right? We don't have all the solutions. So, and I know many. I can point to you some great innovators out there in this space. Our co-founder, John Warner, being, of course, one of, I'm biased because he's also my husband. So I could say he's one of the greatest innovators within the green chemistry space. And of course, I'm going to be open with my bias. But anyway, we don't have all the answers yet in that. But if we have students and innovators, and not just coming in from industry, but also academia, university, and that are helping to create greener alternatives in the innovation space, that's an essential piece to this sort of getting to that sustainable planet. So our organization, Beyond Benign, it's a bit of a tongue twister, but I do like to pause for a moment and just basically say what's with the name. And I think it comes to one of the fundamental principles of what green chemistry is all about, is that beyond just being environmentally benign, green chemistry technologies, they have to work. Goes back to, that statement from P&G, it has to work. Otherwise, people aren't going to use it and it's not going to be successful. It also has to have comparable economics or better economics to be successful in the marketplace. So this makes the job of a green chemist hard. It's not easy. Oftentimes when, I think historically we've often thought of sustainability or in this environmental space is somehow not being as good technologically. Well, I would argue it's harder in order to, be considering of all of these things. So yeah, so that's a central piece to what green chemistry is all about as well. So at Beyond Benign, we focus across the whole education continuum, and really our goals around fostering that transformative change, and primarily with educators. But as you can imagine, with chemistry education, there's all kinds of opportunities throughout this pipeline to use green chemistry as a tool to inspire that future chemist, demystify and spark interest in chemistry, with the idea of having students that want to solve global environmental and local environmental challenges and innovate and solve some of these challenges for us. And then at the undergrad and graduate school level, now we're building skills. We're focused on building skills in chemistry, training those next generation of innovators that can contribute to not just industry, but also academia as well, and implement more sustainable practices and innovate for sustainability. So we're focused across this pipeline. Our programs, we have two main pillars and one that sort of bridges them together. Our K through 12 is a program centered around our lead teacher program. I'm going to mention super briefly, just so you understand, just so you have an idea of what we're doing. And please, if you have educators, either at the K through 12 level, teachers, schools, and then also at the college level, college universities, connect them with us, reach out, share our resources. We always would like more folks in the community. So our three main approaches is we invest in educators, we develop tools and resources, and we foster peer support networks. And we do this a little bit differently. Oh, I copied over an old slide. So these impact numbers are higher. And we have, so this is something more like 7,000, but anyway, but we do have open access lesson plans that are posted on our curriculum page on our website. And we have 95 global green chemistry commitment signers. So we have a growing network. So I think I did that really quickly and copied over an old one. So sorry about that. But basically, we focus on educators because one educator can have tremendous impact. I mean, they see a good, just, looking here in the US, one educator teaches, about 250 students a year on average, they could potentially reach a significant amount of future scientists and business leaders. And even if a fraction of that, percentage of students that see it or hear from that educator bring it to their practice, is still a tremendous impact. So we see them as multipliers of impact. So again, our K through 12 program is for teachers by teachers. We have a lead teacher program of teachers throughout North America, US and Canada. And they help us, they work alongside us in our professional development with their peers, developing open access resources, and then fostering some peer networks. Again, happy to share more and make any connections. These are a good number of our acting and current lead teachers. You can see all the different areas that they're from, and our certified lead teachers who still will carry out work with us as well. In our higher ed programs, I'm going really super quick on our programs here. And our higher ed program is centered around the green chemistry commitment. And this is it's a flexible program for college university chemistry departments to commit to implementing green chemistry. They commit to implementing 4 student learning objectives in their practice. This actually would be a great place if you're looking for, green chemists and you have, you're looking for some recent grads that might have some of these skills. Go to our signers list and go have a look at, find out if there's a college university near you that might have some of this going on, because you would have a better pool that might be more equipped to address some of these things in a career or in a professional setting. So we do have 95 signers globally at the moment. And we have a goal here in the US, our 25 by 25 goal. We graduate about 22,000 chemists annually, and that's across all levels, associates, bachelor's, master's, PhD. And that's, again, annually. We have a goal of reaching 25% of those graduates by 2025. We're currently at 10% with our current cohort of signers, which is super exciting. It's not insignificant, but we really want to build and get to a critical mass And we're going to do that through a new initiative that we just announced last week, which we're focusing on engaging minority serving institutions throughout the US in particular, and globally as well, to ensure participation and elevation of voices within this program, and also just to build a more diverse set of green chemistry education folks as well. So that, and then within our higher ed resource programs, we also develop open access resources. Here's a couple that might have some tools that might be useful to your sector. One is the Green Chemistry Experiments for Undergraduate Organic Chemistry Labs. It might seem completely irrelevant to what you're doing, but the intro section alone has some really great, it's got a really great summary of solvent selection guides and how to think about choosing better solvents in not only organic synthesis, but also extractions and things like that. So it's got some really great open access resources available on our website. We have a new Toxicology for Chemists program that will be posted in August, open access curriculum to go along with our open access theme. And just want to check my time. Okay. And that will be also coupled with some professional development to basically give chemists, which again, we traditionally don't have this in our training, but to give chemists more tools to understand how to use toxicology to better their design, right? So the last program that we have is that middle piece, the GCTLC, and really briefly, this is coming, and we would welcome your participation in the future. This is coming next year, but basically this is a place to bring the community together. We're working with the ACS Green Chemistry Institute on this. It's a virtual platform that will be an open access resource hub that not just our resources, but the community resources. We really hope to have access to green chemistry professionals, job boards, industry discussions, like a nice place to meet and connect. Again, maybe it's that place where you're looking for a green chemist that might help you with some of your research or your work. It could be a connection point. It'll also be open and have forums and discussions and mentoring. It'll be a collaborative space. So we're super excited about that, and keep an eye out. I'm happy to share more on that. We're working with some really wonderful folks in our leadership committee that are from academia, K through 12, and also industry, and they're helping us to guide this platform. It's centered around some core values. We really are really interested in creating a place where people feel they belong and that they're included and represented, and also ensuring equitable access to resources. So there's a lot of work going on, but that'll be coming next year. And finally, really briefly, a couple things that we're working on that are more centered around the industry, sort of the end of this continuum. We're working with the Lowell Center for Sustainable Production on this EcoChem committee, and basically we're collaborating with them to define this term sustainable chemistry. There's been two, and this is the focus is here in the US, but also in the EU, where the Safe and Sustainable by Design initiative is coming out as well. So we're working with a group of an expert committee. That's what this stands for, Expert Committee on Sustainable Chemistry. And you can see the whole list there. I can also drop these in the chat after too, if anybody wants to see anything, the links, because I know you can't like jot it down fast enough or anything. So, but basically we're coming up with a definition of sustainable chemistry and how it relates to something like green chemistry, and then having an actionable and measurable criteria. Here in the US, there was a Sustainable Chemistry R&D Act that was passed. I believe it was last year, and now the White House Office of Science, Technology, and Policy are asking for guidance, and this could really impact the future of funding and support for sustainable chemistry in the US. So we're really interested in really helping to foster that and sort of guide them towards green and sustainable chemistry. So it's exciting, and there's a lot more work coming, but we'll have some open public comments and feedback sessions. So if anybody wants more information, please let me know. And basically, this is my, how does green chemistry fit into sustainable chemistry? These were some slides from John. I'm just going to say, sustainability is broad, and we want it very focused across all disciplines, right? And so sustainable chemistry is really obviously within the discipline of chemistry. Sustainable chemistry is broader than green chemistry, I would say, and it really focuses on the application and the implementation of green chemistry. And green chemistry is the tools really of the toolbox for chemists of how we get there. So that's sort of the link to that sustainable chemistry work. And of course, that's green chemistry there, all the 12 principles. So I'm just going to kind of scoot over to them. My last one, we're working with IFRA on a IFRA and IOFI. So that's the International Fragrance Association, and then the equivalent for flavors on a green chemistry compass. And this, it's really wonderful to see. So this is an industry consortium that has a sustainability charter, and they're wanting to build out more in their toolbox on green chemistry to point their whole industry sector towards green chemistry. I would say this green chemistry compass will be a bit of a higher level focus. It's not going to give folks all of the tools, but we're hoping it can encourage more adoption of green chemistry within these two sectors. So this could be some relevant to some of the work that some of you have going on. So if you're familiar with IFRA and IOFI, they have a sustainability charter, and they have these 5 focus areas and commitments, which again are kind of high level, but they do have some that are more related to green chemistry, and that's where we're focusing in trying to develop out this compass tool. So this will come by the end of this year, and we'll be happy to share that out as well. Okay. So that was a super whirlwind overview of green chemistry, our work, a little bit of here and there. Happy to, chat more, and hopefully, wherever you are on this layer towards achieving a sustainable human and environmental health and a sustainable planet. I mean, we're at the core, K-12 and higher ed, and hopefully you're somewhere in between there, and we can work together towards a better future and a better planet. So with that, thank you. If you do want to, stay in touch, sign up for our newsletter is often the best way to keep up to date with some of our resources and different things. Feel free to sign up. That's what that QR code right there is. You can sign right up for our newsletter if you like. And a huge thank you to all of our sponsors and folks that we work with throughout our partnerships as well. And thank you to you guys. So that was quick.
It was great. Thank you. Michael?
Yes, thank you so much. That was, you were jamming there. And I don't see, I'm looking at the chat, I don't see any questions, but I do have a couple things that I kind of, the takeaway. One on the, like, when you're talking about brands, or you're talking about kind of the interaction, I did a project, it's in packaging, where, there's groups that try to connect, education groups to industry to work on projects. Do you have anything like that's available to brands where they could, get involved with, a product that probably would resonate with a certain, certainly younger age groups with regards to, like, green chemistry principles?
You mean like volunteer opportunities or something like that?
Yeah, or just projects that happen about, like, like, or show and tell of literally, I'm just curious if, you have anything that helps, industry kind of get back into academia.
Yeah, we do a lot of that. I mean, throughout the years, there's things from, and I should mention in the chat, Juliana Vidal is our fabulous postgraduate liaison. So thank you, Juliana, for doing some plugs there, and and she's probably tweeting as well. So thank you. So yeah, I mean, throughout the years, we've done simple things like, we always want to build connections to industry, because industry and what's happening sort of out there in that quote unquote real world in a sense, because that does build bridges to K through 12 and academia. So we develop resources around, that's one of the things that we'll do. We'll develop open access resources around technology that demonstrates chemistry concepts. And teachers love that, you know, K through 12 teachers in particular, but also college faculty, you know, they love figuring out how to make what they're teaching relevant to students. Because oftentimes, like chemistry, if you know, if you remember, there's a huge spectrum of people's experiences taking chemistry, and we often hear all of them as chemists. As you can imagine, sometimes it's taught in a very abstract way and disconnected from your life. But as us chemists, we're often like, chemistry is everywhere. It's part of everything. So making those connections is, we're super interested in that. And there's going to be some really great spaces to do that through the GCTLC platform too. So we're hoping to build those bridges even more. Research, we also have some companies that are providing some opportunities and grant support for educators to make curricular changes. So one of our partners, Dow, has been wonderful in doing that. Target's been our supporter for our toxicology curriculum. So that was an interesting sort of bridge as well. They're really interested in bringing safer chemicals into their stores. I don't know if that answers completely, but yeah, I mean, building those bridges, we're always looking to do that. And I think it benefits both, you know, the academic and education side and industry to build those bridges.
Yeah, I think it was just, if there's if brands or people have interest, could they reach out if they wanted to get involved, or by leveraging, like you said, kind of something that is easier to relate to than
yes, or even if you just want to go, and if you want some tools to like go and talk to your local schools, so the schools know what's happening at this, you know, school down the street, at this company up the street or something, you know. So yeah, I mean, even just those discussions. Yes, absolutely.
Okay.
I think one of the things I'd be interested in, I don't know if it's something you can put on a list for down the road, but because you're supported by a lot of actual chemical companies who are manufacturing these things, if you've been in the industry for a while, you're familiar with the fact that they make formularies that teach formulators how to use their materials. It's been interesting for me because I'm on the far extreme end. You know, I deal only with organic ingredients, and when I say green, I mean about as green as you could possibly get, because I do go all the way back to the agricultural production of a raw material and all the way through its mechanical production. But it's interesting because a lot of them, they'll take these beautiful new green chemicals that they've made, and then they'll have a formula that teaches somebody how to use it and highlights its functionality. And then they'll put it in with a bunch of really crappy ingredients. I'm actually looking at 2 companies on here where I've had that conversation, and they do learn, but it's like somehow or other, they need to understand that. They need to understand that the beauty of these materials, to make them available, they need to give people formularies that are consistent with the value of the single ingredient.
Yeah, I don't know that I have any answers, but I can only imagine. But the ACS Green Chemistry Institute also has a formulators roundtable. They have the pharmaceutical roundtable, and they have a formulators roundtable. I don't know the composition of all the companies that are involved with that. I mean, these roundtables, basically, the companies pool their resources. You know, and I'm not going to speak completely for them because I don't, you know, you guys can reach out to them as well. But, you know, they pool their resources together and try to identify areas where they have common challenges. Like, you know, I don't know, you can imagine like preservatives. We need better preservative, you know, whatever that
nail
might
polish be. Is a huge one.
Yeah, or even like what's the challenge across, but what's interesting is what I've heard. I mean, and again, I'm not going to speak for them, you can talk to them more, but formulation is one of those tricky spaces for collaboration, because oftentimes it's proprietary, just the way that you formulate, not necessarily composition of the ingredients. It's the processing can sometimes be proprietary. So it's hard to have those discussions in a transparent way when you're in a competitive, you know, when you're trying to work collaboratively with competitors. So it is some unique challenges, I would say. And I don't know all the details of what the Formulators Roundtable is doing, but I'd be more than happy to connect you with the folks that help run those roundtables. So
yeah, I'd be really interested to see what they're doing.
Yeah.
Because it's something that I think as an organization, NOHBA would be really interested in. That's how you learn to make better things. And it's also where you can see the holes are. And when you know how to turn to somebody and say, hey, we need, you know, like you said, a preservative, or we need, you know, some kind of a solubilizers or another sticky wicket that we need to address. So there are specific spaces I see. I have one other question on the IFRA project you're doing. Have they, I would assume they're looking at ISO 9532. Is that what it is? It's a natural fragrance ISO standard.
I don't know, but I might just jot that down to find out, actually.
Yeah, I can send you the ISO reference. I think it's 9235.
I don't know. Honestly, it's a new
9235.
It's a new sector, and I know there's been some great work in green chemistry coming out of the fragrance sector. Most of it has come from individual companies doing, you know, work here and there on it. But I don't know that in particular. But
that deals more with naturally derived under the classic EPA definition of naturally occurring substances. So, but that's what 9235, it looks at a lot of fractions of oils and that kind of thing. And I think if you use that as a base and then you add on some of the GMM stuff that's going on, it might be really interesting, because you could expand your toolbox, if you will.
It's an interesting space because it covers both synthetics, naturally derived biomolecules, and then the bio-derived molecules, all of which, I mean, there's a synthesis there, but it's not under the control of humans. So it's really measuring whether or not you can't affect how it's made, but its afterlife is important. Yeah. On the IFRA thing, how long until the compass is going to be available? And would that be something that would, like, if we subscribe to, or if that would be announced through the Beyond Benign newsletter?
Yeah, it should be, and because it should be an open access. I mean, their sustainability charter is also something you can go and just download. It's open, so it should be an open access tool that we can share. But again, it'll be high level. It's not going to give a ton of detail, but we're hoping it's like the first step towards, you know, and that they can dig deeper from there. And that should be, we're trying to get it out for November. There's a conference that I'm dropping the name of that is in, I believe it's in Brazil in November. So that we're targeting that as a release date for it, but you know, there could be hiccups along the way, but that's the goal. Yeah. But yeah, I see the note about the companies greenwashing. I think that's been an issue since the beginning of sort of the sustainability movement. So I don't think it's anything new, but you're absolutely right. Like, you know, there's always that challenge. So I think pushing for transparency is one of the, depending on industry sectors, can be one of the most challenging things, just as we just mentioned in like the formulation example. But I think the more and more transparency, the better. I think that's the main thing that's going to help that. But you know, I don't think we're ever going to get away from that greenwashing issue. It is definitely a challenge. And honestly, like, you know, you look at some of these companies, you know, our supporters and others, you can find examples, some really fantastic, great green chemistry going on. And you can also find some examples of some not so good chemistry going on. So, you know, it's a process. It's a process.
Oh, no.
So.
Great. I just saw the link to the newsletter. Thank you so much for putting that up.
Oh yeah, thank you. Beyond the QR code.
Yeah, I'm going to be following her Twitter handle.
Oh, and thank you, Janelle, for mentioning that we are a 1% for the planet member. Yes, we are 1%.
So anyway, are there any other questions? And Michael, I guess we're going to keep people informed about the next event.
Yep, we're hopefully going to be continuing the conversation, really also around the bio-based and green chemistry application there, and then just continuing the conversation around trying to get more adoption and clarity around the subject.
Yeah. Amy, thank you so much. That was wonderful to see, and I really appreciate it. And I do have to say, because I don't think people realize this, but I do look at universities, and I think that's so important. So I love the fact that that's really kind of your biggest effort, I would say, in Beyond Benign. But I think the first time I met you, which was probably 4 years ago.
I know it's been a little while.
3 or 4 years ago, because it was long before COVID.
Yep.
Was at the time, I think you were in like, I think you told me that it was only like 17 universities had green chemistry programs, which I found shocking. And I'm still surprised at how low it is, that it's only 10% of. I just looked it up while you were talking. There's 4,000 universities in the United States.
But in only about 1,300 or 1,400 offer chemistry degrees. So our focus is on the chemistry degrees, although we do also many more than that teach chemistry. So there's chemistry degrees, and then also just the teaching of chemistry. So, but I would say the green chemistry commitment is an institutional commitment. There's more than just those 95 that are doing some green chemistry for sure. But we're trying to push people beyond those, like that individual practicing green chemistry to bring it more at a systemic level so that we can have change. So I would say it's not. It's probably a lot higher than 10%. I think we have estimates of about 50%. We've been trying to do this. It's really hard to understand the whole field, but we estimate about 50% of the college and universities that offer chemistry degrees have some level of activity in green chemistry, and that's a huge spectrum, right? And then we think that there's a smaller number that's more engaged, and but we think that the awareness is building. For sure. And it's been building quite significantly, I would say, particularly over the past few years.
Yeah, so everybody listening should call their local college or university and say, hey, do you have a green chemistry degree? Just to make it known that that needs to be part of the curriculum.
Yeah, or even if, I mean, we don't encourage necessarily a separate green chemistry degree, but we would like to see green chemistry integrated and interwoven throughout chemistry. So
I want the degree. I want the full degree. That's what.
Yeah. Well, there are some that have popped up, so we can point you to those too.
All right.
You can look for your new hires.
So anyway, okay, well, thank you.
Yeah, thank you.
We really appreciate it, and good luck with all your work, and thank you for your good work. And we'll let everybody know about the next webinar. Michael, any last words?
No, everybody have a great rest of the week and weekend.
Oh, yeah.
4th of
Happy
July.
4th.
4th of July.
Be safe.
All right.
Okay, thank you.
Thank you, guys.